Okay, so now we have a problem where we have a scientist. His name is Dr. Strangelove. And another, here, let's write his name down. I kind of like that name. Oops. Dr. Strangelove. And another person by the name of Major Kong. Now, Major Kong Oh, did I forget an E? Sorry. Okay. Dr. Strangelove and Major Kong. Dr. Strangelove is in his laboratory, and he's watching a nuclear bomb pass by. Now, the nuclear bomb has radioactive material in it. Major Kong is sitting on top of that bomb, and Major Kong looks at the radioactive material in the bomb, and so does Dr. Strangelove. Now, Major Kong says that the half-life of this radioactive material is 2 times smaller than that of Dr. Strangelove's. So, what that means is, this is half-life we're measuring here, and so let's actually put some time here on this, because this is time. So let's call this TS for Dr. Strangelove and TK for time that Kong measures. Now, interestingly, what it says is that Kong says that the half-life is 2 times smaller than that of Strangelove. So if that's the case, how would these two be related? Kong says the half-life is 2 times smaller. Well, if the Kong's time is smaller, that means if we go like this should equal Strangelove's. So if you look at this equation here, which T is smaller? TK, right? The half-life that Kong measures is smaller. And that's correct. That's exactly the situation that we have, because it says his is 2 times smaller. So at this point, the question says, what is the velocity as expressed as a factor of c? In other words, how fast is the bomb going? Well, what we need to understand here is that which one of these two is T naught and which one is T. Okay, first of all, what's being measured? It's the radioactive material inside the bomb. Therefore, who is in the same frame as the bomb? Major Kong, right? Major Kong is sitting on the bomb. Here, let me write a picture of this, actually. I think this would be kind of cool. So here's the bomb. And here is Major Kong sitting on the bomb. And he's saying, "Woohoo!" All right. So if you haven't seen the movie, then go see the movie. But this guy, Major Kong, is in the same reference frame as the radioactive material inside the bomb. Therefore, Kong is T naught. That means Strangelove, who is in his laboratory in some building over here, when he sees the bomb, he's actually, the radioactive material, he's actually measuring T. Therefore, taking this equation and rewriting it, we would say 2 times TK, which is T naught, is equal to TS, which is T. Now this becomes a lot easier to deal with. So T naught, what's the equation first of all? T equals t naught over 1 minus v squared over c squared. Okay? But we know that this is 2 times that, so we just basically substitute it. We'll take that and we'll put it in there. So it becomes 2 times t naught, which is the substitution, equals t naught divided by 1 over v squared over c squared. Now we can cancel out our t naughts, and now if we reciprocate, coming up here, we'll go 1 over 2 is equal to root 1 minus v squared over c squared, and now square both sides. 1 over 4 is equal to 1 minus v squared over c squared, and now we have v squared over c squared is equal to 1 minus 1/4, which is 3/4. And now if we solve for v, we have 3/4 c squared, and now we can go, coming over to the left here, we can finally say v equals root 3 over 2 times c. And that is our final answer. And that's the end of this problem. So that's how fast the bomb's going.